Okay, more problems from section 1.3, and this is number 21, and this is population growth. It says the population of Knoxville is 500,000 and is increasing at the rate of 3.75% each year. Approximately when will the population reach 1 million? Okay, so we know that we have 500,000 people, and each year that's going to increase by 3.75. So each year we're going to multiply that by 3.75% or 0.0375 and add it to that. So that's basically going to be 1. And then we're added 2 plus the 1 is the original amount. So we'll have that plus the 0.0375. So it's basically 1 plus that, and then we just put it together, add it up. So each year we're going to multiply it like that. Like if you have $100 and you multiply it, you get 5%, then you don't, at the end of the year you don't have $5, you have $105, you multiply it by 1.05 and you get $105. So you multiply it by 1.0375 for every year. And we want to know how many years we're going to do that, so that we can call that time, t, we usually call that t. And how many years, or how many times are we going to keep doing that? We'll multiply it each time. So we'll multiply that again by this, and again by that, and again by that, until we get 1 million. Oops, that was good. There we go. 1 million. Well, if we divide both sides by 500,000, then we have 1.0375 t. And if we divide that, 500,000 goes into a million twice. So this is basically the equation we want to solve. We could use logarithms, but we can use our graphing calculator, and there's a technique to do this. So let's just use the calculator to find out what t would be. So we'll get our calculator out here. And we'll graph so clear that. And we'll graph the 1.0375 and to the t, and we don't have a t, so we call that x, so caret x. And that's going to be this part, and we want to see when it's that equal to 2, so we'll graph it. We'll also graph the line equals 2 on the second one. And then where those cross, where they intersect, that's going to be the solution. That's going to be when this value is equal to 2. So we can graph this. And let's go to zoom 10, I guess, and see what happens, or zoom 6, excuse me. And we can see what's going on there. Okay, it's going like that. And there's my 2, and it doesn't look like it's hitting. I'm going to be able to see that. So I'm going to have to go into the window and kind of adjust it a little bit. And it looks like my intersection is going to be over here someplace. It would be positive years anyway. So I can go to my window and I can change that. So I can make my x minimum 0. And let's go for 20 years. Let's see if that's going to work. Keep my scale at 1. Make my y minimum 0. And then maybe go up to, well, it's only going to be 2, so I could actually just go up to 4. And I could actually make the scale 0.5 so it spreads it out a little bit. And now let's see how that graphs. So now we made those adjustments on the window. And you can see, now we're kind of looking, there's our 1.0375 to the t. And then here's going to come our 2. See, this is 0.5, 1, 1.52. And there's my intersection point. Okay. I think we have enough. Let's try it. So we'll go to second calculate, and we want to find out where they intersect, and you see that's over here at 5. So I could just press 5, or I could scroll down to intersect either way, so I can press 5. And first curve. So we'll just kind of get that kind of close to the intersection point, and that's going to be my first curve, so I'll say enter, and then that bounces up to the other curve. So now I got the second curve, and I press enter again. You can't see that, but I'm pressing enter. Do I want to guess? No. So I press enter again. And this is going to give me the intersection point, and that's 18.828. So t would be about 18.828, or if we round off to years, about approximately 19 years. So we'll take 19 years. Okay. 19 years for the population to reach 1 million. Because every year we keep multiplying it by that 1.0375. So that becomes an exponential because we just keep over repeating our multiplications, okay? A times A times A is A cubed, you see. Okay? So I hope that makes sense.